Okay, let's go back to our trigger and let's have our second example. And this is all about enforcing complex data integrity rules. Okay, so let's break this one into pieces and starting off with our create or replace. And of course, this statement normally is a clause that will go into execute or create our trigger object, which is named as a check underscore style underscore trig. If it doesn't exist, it will go into replace. If it already exists as well, of course, definitely will be replaced or not. Being replaced, it will definitely be created this name of the object trigger. Right, so the trigger name, of course, must be a unique one that indicates likely to check the job's related action. So this is what we will going to work with. This check sal trigger might be specifically on a particular job ID. Later we will see here in our before update of our job on employees table. Right, so moving on the second part, of course, we have some trigger timing events over here that each of the before an update will going to be used here. If before, we definitely the trigger will be fired before the update operation is actually performed on the job ID later on. And of course with the employee table, and perhaps the update of job ID over here, update of job ID, the trigger will go into fire only if the job ID column is updated. If other columns of the employees table are updated too, the trigger will not fire. Okay, so we have on employees over here, so meaning this trigger is associated with the employees table. Very obvious that definitely this will fire whenever an update operation affects the job ID. And on the contrary, each of the employee record in the of the respective employee table, of course. All right, so we do have also here some clauses of for each row. This time we've been using here now on our example because example 2, because this is pretty much like one of the complex data integrity rule. So for each row clause means that each trigger will be fired each row affected by the update, this update and update operation. If a certain multiple rows are updated in a single statement, the trigger will execute once for each row, okay, which allow to check the specific values of updated rows, right? So because nevertheless, of course, we need to identify also by declaring a certain variables later for count of the integers or of the jobs. Okay, so we will going to do that one by declaration part here, which in fact that this section will be declared local variable only, and it will be used within the trigger body. And this one is in this case, of course, that this b underscore job underscore count is an integer, which is the variable that will store the count of the body history records of, I think it's one of the employees, of course, and the new job ID, of course. So trigger body, of course, will definitely be in this block begin and over here but of course this kind of a complex SQL over here. Now this PL will definitely execute with this whole block where the logic trigger is defined, and definitely this contains a lot of codes over here that will run whenever the triggers fires. Alright, so you can see that the select count into a B job count here is definitely will be counting how many records on the job history tables, right? So it's a kind of a typical aggregate here, but the condition will be a code later on our job history table whenever the employees is an old employee ID or a new employee ID. There will be either later we mentioned logical and will be there, but certainly that colon old and colon new are like special binding. Basically these are special binding of variables used in the row level triggers. Okay, perhaps this is a kind of complicated part of integrity here, because without this parameter we will not be able to work as the data integrity rules, right? The result, of course, it will count stored will be stored in the variable v underscore count job underscore count, and conditional will be there because we have an if statement over there, that this if statement checks whether the employee has already been assigned the same job ID in the job history table. So perhaps if wasn't, it's comparing, there's a count of greater than 0 most likely there, it means that it's already been assigned, or otherwise, in other words, the employee has already held this job at some point in the past, maybe. So that's why this logic here will going to be executing that part. So there will be a raise application error. Basically, this is a part of a condition. Whenever it's true, employee has been done in this job, it triggers raises, meaning exception handling as well, just like what we were doing on the previous examples. So this is a built-in procedure basically when it comes to PL SQL. In Oracle, raise underscore application error is a built-in procedure. But then, of course, there will be a code between like negative 20,000 to negative 20,999, or probably yet this would be an error message that will display whenever the trigger raises an error. So this employee has been already been done this job. So error will stop, and the update of the operation from completing, and the user will see the error message. So of course, triggering it to complete this condition, it has to end that if statement, and perhaps to end also the trigger, right? So this will mark the end of body of trigger logic finishes here. So in short, that the summary of this triggered logic will check whether the employee has already held a particular job before allowing an update to be made on the job ID, and perhaps the trigger checks the history as well, if it's already recorded in the employee with the use of employee underscore ID, and there's a binding there with the new and old. And if the employee has already been held the just job, it will have a condition of account, which will be satisfied if it's greater than 0. The trigger will raise an error with a custom message. This will appear the employee has been done this job. So of course, the error causes an update to cancel, and the message is displayed to the user. However, if no record is found in the job history for the employee, the new job will going to be created, and updated proceeds normally, right? So a use case for this trigger is very useful in this kind of scenario when you want to prevent employee from being assigned the same job multiple times. For example, in the job rotation system maybe, or tracking employee careers history, you may want to ensure that each job ID is uniquely allocated to the employee only once in the job history table, right? So we'll move on to probably another example or comparison of database triggers and stored procedure from our next slides. Okay, so see you once again. Bye bye for now.